Yeah, thank you. So from what I've heard, I'm replacing a guy that's supposed to be tall and good looking. So, joke's on you. Huh. All right. All right. I think we can start. So today I'm going to tell you a story. I know some of you might be tired already, so you can treat it as a bedtime story. So this story will be about an adventure. And as in any good adventure, there should be a hero. So our story will have a hero as well. And our hero will face a lot of challenges to answer one question: how to test something that's random. So we keep our fingers crossed for our hero. Hopefully he will learn something, and hopefully some of you will learn something as well, or at least you'll have some fun. Let's start. Meet Fredo. Fredo might look familiar to some of you because Fredo, just like most of you, or just like most of us, is a developer. So, it's natural that you can see some parts of yourself in Fredo. And Fredo will go on an adventure. Now, what's the adventure about? Fredo has to write a game that takes 2 players. Each one of them rolls a dice. And if the first player rolls a better score, he wins. Otherwise, the second player wins. Sounds simple enough. I think right now is the time where we can try to look through Fredo's eyes and try to implement this ourselves. Let's start. We start with a class game and with tests. Where do we start? Of course, with tests. So let's, by the way, those are in our spec, so you probably all are familiar with it. So our game should return a winner, right? So we want to have a game, which is game new, exactly. And it should take 2 players. Let's call them Pepin. And maybe Miri, whatever, right? Okay, we want to have it to have a play method. And now the fun part begins, because we expect this game to have a winner, right? But it shouldn't be like Pepin all the time or Miri all the time. So this thing puzzles Fredo, but he's very pragmatic. And so he doesn't let this tiny detail stop him. He writes the code just as he heard business requirement. If game P1 score is bigger than game P2 score, Pepin wins. Otherwise, it's Miri, right? Sounds simple enough, looks simple enough. Let's see if our tests tell us something. The main thing you have to look for here is, are the tests red or are they green? This time it's red, means it's good. We wrote tests that are not covered, right? There's nothing here, they fail. It's perfect. All right, let's try to write some implementation now. Initialize, we take P1 and P2. Of course, we want this to have a play method. Yeah. And this should exactly P1 score, P2 score. Maybe there should actually be a result of a dice roll. So let's say 1 to 6. We've all seen dice before, 6 sides from 1 to 6. And our main logic here. So if P1 score is bigger, P1 wins, else it's P2. All right. And let's see if our tests will work. Only one more thing, attribute readers. All right, let's run some tests now. Look at that. Everything is green, everything is perfect. Fredo is very happy with his code because not only we solved the problem, not only we wrote tests, we wrote tests first, which means it has to be TDD, right? Only one thing left. We have to let the world know. So let's go on LinkedIn, TDD, it's there, it's perfect. Company earns a ton of money, and we want some improvements, right? Because we already validated our idea. It's great, it's fantastic. We need some more. So we have a new quest here. Basically, let's add a draw, right? Because right now, well, it's only one or the other, but sometimes both of them will roll the same number, and like it's supposed to be a tie. Well, that doesn't sound that bad, right? So let's go back to the code, and let's see what can we do here. So first of all, where do we start? With tests, right? And we already have those beautiful tests here, right? So let's try to modify them. We have our else branch. Let's change it to else if. P1 score, game P2 score, perfect. And one more thing, else. It's supposed to be a tie. That's fine. Now, let's run some tests. And the first thing that was unexpected happens. So we just added a new requirement to our tests. At least Fredo think he did. And the tests still pass. How it's possible? Well, Fredo has a group of friends, very close friends. One might even say it's a fellowship. But yeah, he asks them about it, they help him. I don't have Fredo's friends here, but I have you guys. So let's start. What's wrong with this test? It's obvious, so anyone.
They are random.
Yes, they are random. Yeah, that's true. But in this specific scenario, what do you think could be improved? Why did the test pass here, like when we add this here? Come on, I know you know. It's not that late. Of course, because we have those if statements here, right? So because of those, only one of those test branches is run at a time. And this is not what we were looking for, because we either test if the Pepin was a winner or Miri, but we never test all of those branches here at once. All right, so now what do we do? Let's go back to the state where we actually had a code that we thought was working with the tests that we thought were working. So let's remove these additional requirements here. Okay, so what can we do to actually make those tests better now? Any ideas? We want to get rid of if-else statements. So what can we do? Come on.
Monkey patch the run method.
Monkey patch the run. How would we achieve that? Yeah, down the rabbit hole. No. Okay, any ideas? Like any simpler one? Oh yeah, I can hear something I think Fredo would love. That's true. Let's begin with stubs or mux. So Fredo, as experienced developer he is, does of course just that. So we go here, our spec, stub rand. Stub rand. All right. It gives us hope because it looks like someone else was looking for that as well. There's a question that looks like maybe it might be about the same thing. There's like answer, but a bit too long, so whatever. But, oh, look at this. One-liner, that's nice. 6 upvotes, that's even nicer, right? Okay, copy-paste, like it has to be good, right? All right, let's type it here. I will show you the full line. So it's allowed to receive rand and return 1, 2, 3, 4, 5. We actually want to update it a bit, right? 3, then 1, meaning that the first time we call rand, it returns 3, it returns 3, second time it returns 1. And this means that we should be able to get rid of those. But to make sure that we didn't break anything, let's run tests. There's to pass. Okay, and let's validate our assumption. So we should be able to remove those lines, and we should still be good here, right? Let's test it. Perfect. Now we have a test that always tests the first branch here, the line 13. The only thing left is to write another one that actually, maybe we can change here. And let's write another one that returns Muri. Yeah, thanks, Copilot. Let's run it. Now we have two examples. Both of them pass. Both of them look much more reliable than what we used to have here. Okay, now time for the new requirement. It returns tie. Okay, in case we have 3 and 3, we want a tie. Let's run some tests. They're red, as we expected. So the only thing left is to update the code itself, right? Okay, let's run some tests. Outstanding. Yeah, Fredo is very happy. He became like a company hero right now. Of course, something we have to include in our CV, right? And now we're starting to see other companies pursuing our success. Like there's a lot of companies that want to make the same amount of money that we do. But fear not, our business is actually prepared for that. We know how to be one step ahead of our competitors. You might say this is a revolutionary idea. We're going to use a new dice, but we don't call it new, we call it a better dice, right? So previously, the old boring dice had only 1 to 6 scores. Our new one will have 1, 1, 3, 4, 5, and 6. Well, sounds simple. Although Fredo is not convinced it's like a revolution, but the ticket is already in Jira board, so why not? Back to code then. Fredo takes a quick look on what he already has here, and he notices one thing. We actually don't change any of the logic we have here. Like, not at all. It stays the same. Basically, we shouldn't change tests as well, because they should test the logic that we have here. So the only thing that's left, actually, is to change the code that represents the dice roll, right? Because this is what, in fact, was changed. So maybe we could do something like 1, 1, 3, 4, 5, and 6, and dot sample. It's simple enough, right? This is what we want. No 2 here, it's only 1. We should be good here. So you probably already know what will happen when I run these tests. Fredo is about to find out. Yeah, red everywhere. So Fredo's face getting red as well, because we were supposed to do TDD, sorry. It all supposed to be beautiful and easy and fun. And looks like whenever we get a new requirement, it goes down, right? Tests are always red. It would be best to remove them, but probably we wouldn't get an approve on GitHub, so we have to do something about them. Okay, so first thing first, let's get back to the version that we know was working. The one with run. So what can we do now? Fredo actually asked his friends about this, and they told him one thing: solid. Yeah, Fredo knows about solid a thing or two, especially about the O, because O was his favorite letter, the most round one. Yeah, and he remembers what it stands for. It's for open-close principle. And the idea is that maybe this could somehow help Fredo as well. The other thing is that he notices that although the game looks like we should roll a dice and then compare scores, select a winner, we don't actually have a dice anywhere here in the code. So those lines from 9 and 10 should be represent a bit better. Maybe we should even introduce an abstraction here, something that we can call a dice. Let's do that. Let's call it dice. And it should return the same, right? Round 1 to 6. Okay, let's try to include this in our class. Dice new, of course, attribute reader. And what we need to have here is also a variable. All right, before we do anything else, let's make sure we didn't break anything. Tests are still green, that's good. Let's maybe try now to include this abstraction here. Awesome. Tests are still green, which means we actually did a proper refactor here, right? Nothing's changed besides the implementation. So the behavior stayed the same. That's good. However, how did that supposed to help us? We still have a dice that rolls, right? And it rolls randomly. However, if we somehow could, in our workshop, machine a dice that rolls in a very specific way, we could then use it in our tests, right? Because if we know it always rolls 1, we could test for a tie. So let's see if Fredo is able to somehow machine this dice here. We can call it fake dice. And now we want to be able to define those rolls on the go. And of course, it has to have a method roll, right? I think it's called dice typing, right? If it looks like a dice and rolls like a dice, it's a dice. I heard that somewhere. Okay, let's see if we can somehow include this fake dice in our tests. Maybe we can do a dice. It's a fake dice, okay? Let's include it here. And let's run our tests. Nothing's changed, which is good, expected. Now, if our assumption is correct, we should be able to actually remove this line. Let's see what happens now. It still works. Great. Now let's just do this for the rest of the examples. 1, 3, and here we want 1 and 1. And let's remove those lines. We don't need stubs anymore. No, I had to, like, of course, forget about passing dice. Okay. Perfect. We'll still, in the very beginning, meaning everything works kinda as it used to, but there is one more important thing here. Our class that we were testing no longer cares about the dice and the type of the dice, right? It only cares that it rolls. So to achieve our goal, we have to do one more thing. You remember how we call it, right? It's better dice, not new dice. And here we implement sample. All right, now we replace this dice, this old boring dice, with better dice, and we run tests. Tests are still green because we don't really care about the dice anymore. We only care that it rolls, and we test this, what we have here. Perfect. So you probably know what this is called, and if you don't, you can follow Fredo on LinkedIn. It's called dependency injection. All right. Company is very happy. Yes, there's the question.
Are you using the fake dice?
Yeah, the tests are using the fake dice. Yeah, that's right.
So should we also test those better dice somehow?
Yeah, in real world, we should. I would actually suggest testing like kind of end to end, or like not unit tests with fake dice only. But it's not a real world; it's a story. Yeah, but that's a good point. We actually should include those in tests. Only if you want to test this with unit tests, you can go ahead and use like a fake dice. Okay, we did it. Our company is happy. Very rich company now. We're also very rich because look at our resume. So there's one more problem here. One last tiny thing. Our code looks like it works perfectly, but we still get call from this one customer. And he tells us that, well, I play with my friend. I roll 5, he rolls 1, and I still lose. So it shouldn't supposed to work like that, right? Yeah, it shouldn't. And Fredo is a bit angry because the tests are showing that everything works, right? Tests are green; it has to work. So he was about to grab a phone and kindly explain to the customer why it works. But on the other hand, I think he briefly remembers the project. Maybe you also remember such projects where tests were green and yet features didn't work. Like, have you? Anyone? Yeah, less than a half that I hope for. All right. Tests are green, but can we actually prove that our code works? Fredo talks with his group and has an idea. Right now, when the game ends, we know who wins, right? But it would be really, really nice if we could tell why that person won, right? Because look at this in this way. If player 1 wins, it means that he could have rolled a 6 and his opponent could have rolled a 1 or a 2 or a 3, yada yada, right? So there are many events that lead to the same result. It would be really nice if we could somehow track this. So he gets an idea. It would be really nice if we had a game that actually returns some events, some logs, some audits. So let's say that our fake dice rolls 2 and 1. We want to have an event. Maybe I can show it better here. We want to have an event that says that Pepin rolled 2, Miri rolled 1, and that the winner is Pepin, right? Because then we could exactly know what happened and why Pepin won, not only that he won. All right, so to do that, we add, of course, events here. And let's initialize it. And now, this is important. After each one of the state changes, meaning every time we use the instance variable or assign a new value to it, we want to log it. So player 1 rolled something, P2 rolled something, and finally who the winner is. Because right now, you can actually take a look at those events. Maybe you can store them in a database. Maybe you can log them somewhere else in like Sumo Logic or Datadog or whatever you use. And you can actually follow the full execution of your code, see what was happening, and assert if the code actually behaves as I expect it to, as we have written in tests. So one final thing, tests are still green. Everyone is clapping. Fredo learned a new skill. And yeah, with such impressive resume, he becomes a president. And his journey ends here. But ours does not yet, at least. I'd like to go through some of those tests with you and talk a bit about them. So let's start with the ones with conditionals. So those are very, very obvious examples of how not to write tests, right? So we have logic in tests. That's the main problem. What's bad about it? To be fair, I don't think there's anything good about them. But so what's bad? Well, logic in tests always makes them harder to understand. Logic in tests that mimics the logic in code actually means that you're probably not testing anything, and it gives you very false sense of security. So, like, don't use it. Yeah, and now a question. Who uses logic in codes or ever seen? Like, hands up. No one, yeah? Okay. In tests, sorry, logic in tests. All right. So there are different flavors of logic. Have you ever seen like a loop in tests? Yeah, it's logic. Because like, why is it bad? Not every logic is bad, right? But when you have a loop like that, you test like 100 products, and the test fails, right? It returns 101 instead of 100. So for which product did it happen? Like, it's hard to tell. It should be understandable immediately. Have you ever seen something like that? Like, I've seen that. So we have this nice serializer that turns cents to dollars. And, you know, our code already uses it, so let's use it in our tests. Well, yeah, but if cents to dollars break and start returning null, our code will still pass, and but our feature won't work. Okay. The second thing, the one with stubbing. So now we're getting to the more controversies and why it's good, why it's bad. So the good thing is that we are actually testing things, and we're testing all of them. Another good thing is that those tests are deterministic. So no matter how many times we run them, we expect the same thing to happen, which is good. And those are easy to write. Let's acknowledge that, because I think this is also very important. What's bad about them? Well, they make your code coupled to implementation, which might make refactoring much harder, as we've seen in this example. Okay, so hands up, who uses stubs or mocks in codes? Yeah. So have you ever seen something like that? Like where you have message chain? This is an actual example from my code base. I only changed, you know, the variable's name, but the amount of those attributes is accurate, and like, good luck if you want to refactor it anytime soon. Also, you know, results is a double. It allows result to return something else, which returns another double. It's hard to understand, and tests are supposed to be easy. Yeah?
Can I ask a question?
Of course.
If you use the dependency injection, like to inject like if a client or any other like external like library, you don't really want to test the result. You want to kind of like stop it. So if you have the documentation for the external API, the object you're injecting into your class, you will have the fake dice really, but this kind of like expect to receive the role could be useful, because this is the only thing that you want to test in unit test. If the external object you can say actually is called the right way, like this is documented in the documentation.
Yeah, I fully agree. It can be useful. It just comes with a price. And like, as long as you're aware of that, you're good to go, right? I'm not telling that you should avoid using any of those things, or maybe conditionals, like, no, don't. But honestly, yeah, it comes with a price. And there are like functions, methods that we don't really care about what they return, but we only care about side effects, like an API call, right? And we have to test it somehow. And I think this is like a good and easy and low-cost way to do that. And maybe there are more benefits than, hassle with refactoring later on. Or maybe we won't be ever refactoring this, which is, even better, right? So yeah, if it works for you, work with it, right? But if you start using stubs everywhere, like ask yourself if it's worth it. And if you see like receive message chain, this should actually, light up some heavy orange lights in your head. Okay, let's go to the dependency injection. Yeah, anyone uses something similar in tests? All right, how does it work for you? Is it fun? Is it easy to implement?
You mean this different class, right?
Yeah, you use a different class specifically for tests.
I come from something that's called well-work. Is actually maybe talking about tomorrow, I think, and it's called substitute. I don't know if you derived from there as well. I have problems with convincing other to accept non-production code. They seem to always say, hey, it's not production code, so what are you actually testing? So this is the approach I find with. Yeah, I can do it.
Yeah, I can feel that. It's hard, but if you, instead of making a new class, you use, if you, instead of using new class, you use instance double, then suddenly it becomes really, yeah, it's okay, it's fun. We all do that, right? So first, let's talk about what's good, in my opinion, in injecting tests, like in dependency injection tests. It lets the code to be open, which is actually a big thing when your code changes a lot. Those are still deterministic, and we gain some decoupling from implementation, which is actually very good because it makes refactoring much easier. What's bad about it? Well, first of all, as you mentioned, some of the people don't want to do it simply on the preference, and that's fine. Fake dice needs to be added, like it's a code, right? I mentioned before that when we add code or logic to tests, it makes them less readable, and we just added code to tests, right? We should avoid that. We'd like to. Second thing, we need to make sure that fake dice and dice stay aligned, right? If methods on a dice change, we should change them on fake dice. It's tricky. And lastly, if we pick the wrong abstraction, there's a big chance that further on, we will regret it. It will make the code more complicated than it needs to be. And there's like one thing here I want to point out, because I can see a lot of instance double uses, and it's nice because it actually guards us from using like method that doesn't exist, right? What it doesn't help us is returning value that's actually not possible to be returned, right? Here, calculate method returns an integer, and in our instance double, we return string. If we do something like that in our tests will test something different than our code. So something to keep in mind. All right, so what about the tests with monitoring? What about monitoring like in general, right? Or logging, like whatever you call it, auditing. It's actually a very good idea. I highly recommend it, especially in important parts of your system. It makes debugging like a lot easier. It gives you audit of changes, and like at the very, very last thing, it gives you ability to manually test it. If you have complicated algorithm and you know all the inputs, you can like use your calculator in your phone and test if the value is actually matching the one that was calculated from your code. Of course, if you use the technique that was already mentioned yesterday and a few times today called event sourcing, you like have this for free, right? Because you already have those all events that alter the state of an object. What's tricky about logging? So first of all, if you overuse it in your domain code or in the code that cares about business logic, it becomes hard to read because you log everything, right? do something, log, do something, log, do something, log. Second thing, if you don't properly choose the tools, you might end up with like a pricey bill. Because if you log extensively under heavy traffic, your sumo logic bill might increase. Maybe, think about it. Maybe it's better to store them in the database. Maybe a simple Datadog metrics would be sufficient. Like, pick the right tools for the job. And I also recommend using this with legacy code. It actually helped me a few times with understanding and debugging the code. Because when you have big ball of mud and you add logging to the mix, you will still have big ball of mud. But you might understand it tiny bit better. So I recommend you to try it. Okay, so now back to the original question, how to test randomness. In my opinion, don't test randomness. Try to understand it, try to extract it, and at the very end, try to control it. Yeah, so you might think that there is no randomness in your systems, and you might be right, because why would be? But there's one thing that looks very similar to random things, right? Maybe some of you seen a piece of code like that somewhere in the system, like time current, right? I bet if we all right now run Rails console on our MacBooks, we all would get different results. It kind of looks like it's a random thing, although let's be real here. It's not that complex, right? This code looks pretty simple. So here is my favorite solution to how should we test it. Time travel, yeah, only option. To test this fairly straightforward piece of code, we need to use time traveling. Okay, that's it from my side, but I have one more question, or maybe one more favor to ask you. This QR code leads to feedback form. There's a slight chance that I might give this talk sometime in the future. So I would really appreciate it if you could give me feedback. It's really quick. You just open the form, you type in, I hated it because, and this is the important stuff for me. Okay, thanks. That's all from my side. And if you have any questions, I will be happy to answer. Yeah.
I just want to challenge your statement, the last statement, that the time travel is the only thing to test the time current or time now. Like, I know two other methods, and one is the effects, like algebraic effects, and the other is the dependency injection, actually, when you can have like a single current time initialized per request or per whatever process you have and inject it down to the system. So, yeah.
Yeah, I mean, I 100% agree with you. This is probably much better. And you can use stubs or whatever, like probably even some logic that I show here. I agree. And yet I still sometimes see a piece of code like that in our system. So I agree, you're right. You can test it in many different, better ways. So yeah. And yet still, there's time travel methods in our spec. Yeah, any more questions? All right, then thank you very much.
Okay, one more question. As we've said during the presentation, usually there is this talk about that piece of code not being really a production code. Do you ever keep it with production files? Because sometimes, well, this is a dice, and in your example, this is a dice. But sometimes this kind of object is useful between tests. Like you need it for multiple tests. For example, if you have this, for example, maybe specialized time object, for example, do you ever keep it with production code, or does it belong to the test code for in your place? Project?
I never keep it with production code, and like I take the hit if I need to change it. Like if I need to share this between tests, well, too bad. I will write it twice, 3 times, 5 times. Although like it doesn't happen often, but I personally rather have this in few different places because it's like a rare thing to change. So, you know, I'm okay with that. It might not be perfect solution for you. You might want to use like kind of helper or something like that, maybe, or a factory. It might be better for you. But I would avoid keeping this with code, you know, just so things don't go wrong, right? So I would clearly state that this is test thing only.
The one thing might help with is this alignment between the fake the new presentation object and the real one, especially when it's more sophisticated.
You're right.
I actually have a comment about this. One technique I've seen used successfully to ensure there is like an alignment between the fake implementation and the production implementation is to run a suite of tests against both production implementation and the fake. And in this example, it wouldn't work so well because the fake days is a bit special because it's random. But often you have stuff like repositories. And you can make sure like that when you write something, you read back the same thing. And if you have such a suite of tests, you could potentially run the same test against the production implementation, which would write to the database, and like in-memory implementation. And this way, the chances are a lot better of those two staying in sync. Another like thing that is important, especially if you develop in like many teams, is that the team that owns the production implementation should also own the fake. And ideally, they would always provide the fake if their implementation is slow, for example.
Yeah, that's a good point. Testing both of those solutions, the fake one as well, is a really good approach. I think even if you read like 99 Bottles or maybe this practical object-oriented design in Ruby by Sandy Metz, she mentions that way. And I think that this is really good. Although if you already have problems with convincing your team to use fake code in tests, try convincing them that they have to test it as well. Like it might be troublesome, but I honestly really like this approach.
So also my comment for keeping consistent returns from those both classes could be RBS, which will do this automatically for you if you include this in your RSpec tests.
Something I don't know nothing about. So yeah, the
RBS is this typing system.
Yeah, but I never used this that way.
Yeah.
But it's a very
table.
Interesting idea.
Okay, no more questions. Thank you very much.
Thank you very much.
Okay, so